Hello. In this video, we're going to look at some more applications of quadratic functions, and we're going to look at optimization. Now, the term optimization really scares people when they hear it. They think it's something really esoteric and difficult to understand. It's really not. All it means is maximum or minimum. Remember, if you were to graph a function, if it opens upward, it looks like that. And notice that the vertex is a minimum. But if you had a parabola and it opens down like this, that parabola, or the vertex of the parabola, is a maximum. That's really all we're talking about when we say optimization. So please don't get freaked out from this. Rule number one of mathematics, don't freak out. Okay, with that in mind, let's go ahead and look at this example. It says a firework is launched from ground level with a muzzle velocity of 144 feet per second. The height s of the firework t seconds after launch can be modeled by the function s equals negative 16t squared plus 144t. When will the firework reach its maximum height? And what is that maximum height? Okay, so we've actually got two different questions here. We have a question that says, when will the firework reach its maximum height? And the second question asks, what is that maximum height? So here's the thing. Keep in mind where it occurs is the x value, and what it is the y value. Now, I'm using x and y here for the independent and the dependent variable. In this particular situation, the s is taking the place of the y value, and the t is taking the place of the x value. So just keep that in mind. So, with this understanding, if we want to know when will the firework reach its maximum height, I want to know what is the independent value of the vertex. And so maximum there is really what's telling you vertex. So let's go ahead and find the vertex. Let's find h equals negative b over 2a. And the function itself is s equals negative 16t squared plus 144t. And in this case, a equals negative 16, b equals 144, and just keep in mind c is 0 here, because there is no constant term. So let's plug in the 144 and the negative 16. We get h equals negative 144, all over 2 times negative 16, which is negative 32. And actually do the division, type it into the calculator if you wish, and that's going to give you 4.5. Now, this is 4.5 for the t value. Okay, now I used h here. You don't have to use h. You can say that that's t if you wish. That's perfectly fine, because it is the t coordinate of the vertex. Okay, so now that we know when it reaches the maximum height, we want to determine what is that maximum height. To do that, I'm going to plug in the 4.5 into the function. So it's going to give me negative 16 times 4.5 squared plus 144 times 4.5. And then just type that into your calculator and simplify it. I'm not going to do all this in my head. You shouldn't either. And that's going to give you s equals 324. And the units here will be feet. So seconds and feet. Awesome. In answer to the questions, it reaches the maximum height after 4.5 seconds and the maximum height is 324 feet. Awesome. Awesome possum. Awesome blossom. Awesome potato? I don't know. Anyway, I'll go ahead and leave it here, and I will see you in the next video. Have fun.